Yes, so welcome all of you. In this video, you are going to learn about the DC drives. DC drive means DC motor. DC motor, you will going to control the speed. So DC motor. So DC motor, you want to control the speed. So what about the power modulator? Last unit you have seen about the power modulator. The power modulator source, then power modulator, DC motor. So I will repeat: source, power modulator, DC motor. So your power modulator, what is your power modulator? The power modulator is a possibilities are the three possibilities. One is you can use as a rectifier. You will going to use, or second one you can use as a chopper, or third one you will going to use as a dual converter. So these three. So I will repeat. So your drive is, what is that one? DC. So DC, that one. What is that one? Source. The source is either AC or the DC. So between here source and then your motor, what you have connected? Power modulator. The power modulator, AC to DC converter or DC to DC converter. So any one of the method. So AC to DC means rectifier, or DC to DC I wanted means chopper. Okay, so two rectifier I am using. Why I want two rectifier? One for that forward motion, another one for reverse motion. So that is nothing but a dual converter. So this is a topic you are going to see: rectifier, chopper, and a dual converter. What is a dual converter? Two rectifier. Rectifier A, inverse of the A. Rectifier A, inverse of the A. So inverse of the A. Okay, inverse of the rectifier or negative rectifier. So dual converter is a rectifier. You can say positive rectifier, negative rectifier. Okay. Then one more topic we will going to see about the closed loop of the drive systems. It's nothing but how electrical vehicle is operated. So last unit we were discussed, that is the same closed loop drive system. So electrical vehicle Hall effect sensor is not placed. If it is a Hall effect sensor is not placed, means the system is never operated. So Hall effect sensor giving that position of the rotor to the controller. Controller is giving the command to the converter. So like about that one, closed loop system is important. You are going to learning now. So how much it is important? If Hall effect sensor is a failures, means your drive is not operating. And further, what you will going to see? So you are using about the DC. So DC drive. So DC motor. So you will going to review about the DC motor with respect to the classification you want to know, and the speed control methods. What are the speed control method, and what are the electrical braking systems? So important question about that one. So electrical braking systems, they will going to possible to ask, and the rectifier, chopper, and dual converters. So these are the possibilities from the unit. The closed loop also, it is important. So first one you will going to see about the DC motor. So generally classified in that DC motor, it is a two method is there. One is separately excited, second one is self-excited. Self-excited further classified into the shunt motor, series motor, and the compound motor. What is a compound motor? Combination of the shunt and the series. Then this is a motor is a further classified into the long shunt and the short shunt. Long shunt and short shunt. The compound motor is classified long shunt and short shunt. Each long shunt also cumulative and differentiative. What is a cumulative? So these two flux are the cumulations. That's why it's a cumulations. What is the difference about that one? These two, shunt and then series of that one, it's a difference. So it's a cumulation and a differentiations. So it's a general classification. So generally DC motor means three types of motor. One is a shunt motor, series motor, compound motor. You know, separately excited always we are using about the shunt motor. So shunt motor here is a present and here also present. Self-excited also shunt is present, and separately excited also shunt is present. Always we are preparing about the separately excited shunt motor. Why? Because the speed control is more flexible, reliable. Okay, field winding is separate. So you will go to armature is a certain open. It doesn't affect it. So that all of the purpose, reliable purpose. Separately excited speed control is good about that one. Then self-excited series motor always we are going to prepare. Then see there. So separately excited. What is separately excited? There is a two winding. In the DC motor, there is a two winding. What are the two winding? One is a armature winding, another one is a field winding. So which winding is a rotating winding? So see, easy to remember, it is a round shape. Okay, so it is a rotating winding. What is a winding? It's a armature winding. Armature winding is a rotating winding. And then this is about the field winding. Okay, so how this is a rotation is take place? You will going to give the power supply to that both winding. Okay, both winding, both fluxes are created, field flux, armature flux. These two flux are interacted. Okay, interacted, and torque is a take place. Okay, torque is take place in that rotating winding, and it will going to produce. So once it is rotation is produced means, okay, small voltage is produced. That voltage is go flow this directions. It will go to flow in this direction means opposite to the supply voltage. That's why it is called a back EMF. That's why it is called a back EMF. So separately excited, self-excited means both the field winding and armature winding both are getting the common power supply, common power supply, common power supply. So this is about what that one, self-excited. Okay. The next one, characteristics. So what is a characteristic of a shunt motor and a series motor? So these two is shunt motor. Okay, one is separately excited, another is self-excited shunt motor. We need to see about the characteristics of the shunt motor and the series motor. So these two, what is the characteristics behind? Shunt motor is a constant speed motor. Okay, constant speed motor. Why it is constant speed motor? T is directly proportional to the IA. What is the general formula? T is directly proportional to the pi into IA. So here pi is a constant. So that's why T is directly proportional to the IA. So that's why you will go to constant torque. Our starting torque is a medium. Okay, constant torque or medium starting torque. Okay. The next one, N is directly proportional to the EB divided by pi. N is directly proportional to the EB divided by pi. So here is a pi is a constant. So N is directly proportional to that EB, back EMF. So N is directly proportional to the EB. So that's why it's a constant speed. So moderate starting torque. So shunt motor means moderate starting torque. T is directly proportional to the IA, and then N is directly proportional to the EB. It is a constant speed motor. What about series motor? High starting torque. High starting torque. Why it is called high starting torque? Torque is directly proportional to the IA squared. Torque is directly proportional to the IA squared. Why? Because flux is not constant. If flux is not constant means flux is equal to, both are the series connections. So IA. So flux is equal to IA. So T is directly proportional to the IA squared. So that's why it is about the series motor is a high starting torque. And here is the N, general formula. What is the N is directly proportional to the EB divided by pi. So here is a flux is increase, speed is decrease. Okay, inversely proportional. So that's why variable speed. If I have see about that a shunt motor and a series motor. What about that one? See here is a, what is that one? Torque versus the armature current. T is directly proportional to the IA. So that's why linearly increase. So what about here? T is directly proportional to the IA. T is directly proportional to IA square. So before saturation and after saturation. So before saturation and after saturation. The next one, speed versus the armature current. So in that one, what it is showing? So speed is directly proportional to the EB divided by pi. Pi is a constant. So speed is directly proportional to the EB. So almost constant. Practically lightly it is a drop. IA or a drop. So almost constant. So that's why it's a constant speed motor. What about here? Speed is inversely proportional to the flux. If flux is increased, speed is decreased. So that's why it will go to variable speed. The same diagram is repeated here. Same diagram we will going to repeat it here. Here is a written, what is written? Speed is written. Speed you can write. Speed is written, speed is right. With respect to the torque, this is a, where it is the another, this is a torque. You can write it here. If you are going to write means that is a curve. This curve is called a mechanical characteristics. Speed versus the torque. Torque versus the armature current means what is this characteristics? This is called electrical characteristics. So electrical characteristics means this one. Mechanical characteristics means this one. And so it's a cumulative compound motor. Cumulative of the two fluxes and the differentiation of the two fluxes. So this is about the electrical characteristics. And then here, okay, speed versus the armature current, or that one, speed versus the torque. So cumulative and differentiate. Then next one is a speed control. So generally three type of the speed control method. One is armature control method. Then second one is a field control method. Third one is applied voltage control method. If source is reduced, automatically the flow of the flux into the armature as well as the field is reduced. So the torque is reduced. So automatically motor speed is reduced. So this is a way. Source is reduced, automatically speed is reduced. This is a method of the control method is called applied voltage controlled method. The next one, armature controlled method. What is armature controlled method? So one variable resistance is connected series with the armature winding. So one variable resistance is connected series with the armature winding. This is a vary. If you have vary, the flow of the what is that one? Voltage. The flow of the voltage it will going to vary. You will going to control the speed. You will going to control the speed. See, if you have series resistance connect or one resistance variable rheostat, you can connect a series with the armature winding. When you will going to vary this one, the flow of the voltage is vary. If you have low voltage, automatically speed is low. So like about that one, it is called armature control method. The next one, flux control method. What is a flux control method? One variable resistance is connected a series with the field winding. Okay, series with the either the shunt motor or the series motor, whatever. So you will going to connect it in series with the field winding. If you are going to vary this one, the flow of the current to the field winding is varied. If the field current is vary means flux is vary. So flux is vary means this flux and this flux interaction is vary. That's why it is a field control method. Okay. This rheostat you will going to seriously connected or across you can connect it. If you have across connected means that is called a divider. Okay, that is called a potential divider. So here series winding, field winding and armature winding. So this rheostat is well going to connect it. That's why it is called a divider. So divider. Or one more, what is that one? Suppose I will go to tap changing method, tap changing auto transformer. How the auto transformer is working? When you will going to vary the knob, the winding, the turns it will going to vary. Similarly, the field winding turns is a vary. If I vary that one, what will happen? The speed is a vary. This is a method. Come under the field control method. But practically, it is a complicated one. Then rheostat is used to, you can achieve. Okay. Then what is the difference between the shunt field winding and the series field winding? More number of turns, less number of the turns. Thin wire, thick wire. That's a differentiation. Yeah. So see about that one, series winding, series motor. These two are connected in seriously connected. Field winding and armature winding. What are the possibilities of the speed control? Speed control. So variable rheostat is connected across to the field winding. Okay. You will go to field divider method. Or a variable resistance is connected across to the armature winding. So armature divider method. Tap changing of the field winding. Or here is this field winding is totally, I will going to split it into the two. So if I want to speed control, so I will, this is a line, here I will going to keep it on switch, the switch is open, so the flow of the current to the winding is reduced, so only less number of turns, speed is reduced. So this is a method, okay, general about that one, these three methods. And one more topic in that speed control method is that is called Ward-Linode speed control method. This is a diagram is represented for that one, Ward-Linode speed control method. In industry, you will going to use for that this method. Okay, our main aim is about that M2. M2 is we need to speed control. What are the three possibilities means? This M2 field winding is there. If field winding I am varied, okay, I will going to vary means field control method used to I will going to vary. So if I will going to vary this one, motor speed is controlled. This is a method number one, possibilities number one. Then what is the source? Source is getting from the generator. If generator output is a voltage is produced, that one I will going to vary. How do I will going to vary? With help of this rheostat, field winding. Which field winding? Generator field winding. I will going to vary. This is second method. If I will going to vary, automatically output is varied. Then third one, what is the possibility? The generator input is a prime mover. This prime mover is a electrical drive type of prime mover. This one is I want to vary. How do I will going to vary? This motor field winding. So this one I will going to vary, automatically output is varied. So this is a like about the three possibilities method to you will going to achieve the speed control of the M2. That is called the Var-Lenard speed control method. The next one we're going to see about the braking systems. So generally three type of the braking systems. So rheostat or dynamic braking systems. So what is a rheostat or dynamic? Rheostat is used to apply the brake. How? So general motor, see this is a normal diagram. Power supply applied to the field winding of the motor and the armature winding of the motor. Whenever you want to apply the brake, you remove the power supply flow to the field winding. You can remove and connected across one rheostat. If I have connected across rheostat means the back EMF is generated in the motor. It will going to flow to the rheostat to dissipate it. Then slowly it is coming to the braking. Slowly it is coming to the braking. That is called a rheostat. So rheostat is used to connect it across to the armature winding whenever you want to the brake. And then you will going to coming to that one normal operation. That is called a braking system is called a rheostat or dynamic braking systems. Then next one is a plugging. Plugging means what is that one? Already we had discussed how to change the direction of rotation of the motor. Either interchange the armature winding or field winding. If I have interchange means what will happen? The speed direction is reverse. Speed direction is reverse. Like we had discussed about that one, four-wheeler. So four-wheeler is my four-wheeler is a brake failed. So in that one four-wheeler, it is now rotating on that one second gear, 30 km speed. I am driving on the forward directions. Okay, I want to apply the brake. What to do? I will go for that one reverse. If I will going to go to the my gear in reverse, it will going to oppose the motion. It will going to brake. Similarly here, normal running conditions. Okay, when you want to apply the brake plugging method, so these ones, what about that one? A1 and A2 direction is changed. See here is a plus is going to the A1 instead of A2 you can go, plus is going to that one A2 and then through that one. Through rheostat is I am used. Why? Because of that one is a produce the current. Here is a produce that one due to the changes, due to the sudden changes. Due to the sudden changes, what will happen? So forward 30-degree running due to sudden changes. So due to the sudden changes, what will happen? It is motor is replaced into the generator operations. The machine is generating operation. That is generating operation. For example, plus 30. Then change the sign. Then slowly it will go to what is the normal? It's try to rotate on the reverse direction. So plus 30 into the plus 30 it is reduced to the 0. How it is slowly reduced? Plus 30, plus 20, plus 10, 0. Then if you have continue, you can wait. Then minus 10, minus 20, minus 30 it will going to reach. So once reach the 0, you can switch off. So this is about that one plugging method. Then third one is a regenerative braking. What is a regenerative braking? It is a helpful for while apply the brake, the energy is generated. That energy is generated energy I want to utilize for charging my battery, etc. That is called regenerative braking. Where it is applicable? It is applicable well for that one is with respect to your load. What is your load? It is based on that one. It is applicable. So if you want to see about the regenerative braking, you want to general things you want to know. What is the general things you want to know? The machine is when it is operated as a motor, when it is operated as a generator, you want to know. When the machine is operated as a motor, getting the power supply, back EMF is produced lightly. The speed rotation is less than the synchronous speed. The speed rotation is less than the synchronous speed means motoring. The speed is greater than the synchronous speed means generator. Okay, so now you can come to that one. Just you can assume you are in the two-wheeler or a four-wheeler. Now you are driving the vehicle from the top of the hills to the bottom of the hills. Two-wheeler. Just you can assume you are sitting on the two-wheeler. Okay. Now it is the top of the hills to the bottom of the hills. You will go to riding. So your vehicle in that position. I mean, you are not start the vehicle. I mean, what is that one? Neutral only. What about that one? your motor, your wheel, without you will going to give the accelerator, the vehicle is moving from top of the hills to the bottom of the hills. You have to see how much speed is rotated. The speed is rotating very high speed, top of the hills to bottom of the hills. The speed is high. The speed is high compared with the first gear of the two-wheeler. So you have just assume you are sitting on the vehicle and the vehicle is moved from the top of the hills to the bottom, top to bottom you are traveling. You are in the neutral positions. What about your speed? The speed is 30, 40, 45. Like the speed is increase. Okay. What about your normal, your motor, first gear speed? First gear speed is a normal, it is a 20. 20 is your normal speed. Now what is the speed is rotating? 40. So above the no load speed it is rotating. Above the no load speed is rotating means it is act as the generator. That means above the synchronous speed it is rotating. So it is act as a generator. So that's why it is called for dynamic, regenerative braking. So that's all about that one. The same thing is applicable for that one. Here DC series motor also. But a DC series motor regenerative braking is not possible. I want to use for regenerative braking in the DC series motor means, so DC series motor, that field winding you can connect it in the separate sources. Separate sources. It's a separate source means it's nothing but almost similar to that separately excited shunt motor. Separately excited shunt motor. Yes. So that's why that regenerative braking is not possible for DC series motor. So that's all about the braking of the systems.